So we've seen that short-term memory seems to be encoded in an acoustic format, at least in as much as when you ask people to, hold in short-term memory a list of letters, if the letters sound the same, people tend to confuse them. Whereas if letters don't sound the same, that does not happen. So this seems to indicate that short-term memory, information in short-term memory is encoded in an acoustic format. Now, a different question is, how about long-term memory? What is the format that information is encoded in long-term memory? And there are two key studies I want to show. The first one is by Grossman and Eagle. And so what they did is they gave participants a list of 41 words to study. And then after a delay, I believe 5 minutes, and this was to ensure that what they were tapping into was long-term memory and not short-term memory. So they'd have them study the list, then they'd give them a delay of just about 5 minutes, I think. And then they would do a recognition test. In fact, a recognition test with distractors. What this means is that, imagine you're the participant, you study the list, I let time pass. After 5 minutes, I give you a new list. And for every word, you have to tell me if that word is one of the words you studied, or if it's, or if it's a distractor, if it's a word that was not in the original list. Now, what was particularly interesting about this is that the distractors were divided into semantically related distractors. So words that were semantically close to other words in the list that you studied, whereas others were unrelated to the words that were studied in the list. Turns out, when the distractors were semantically unrelated, typically participants were pretty good at detecting them as distractors. So they didn't quite commit as many false alarm errors, meaning they didn't quite as often believe that semantically unrelated distractors were actually words that they had seen in the original list. Conversely, and this is the interesting aspect, when they were shown semantically related distractors, again, words that were not in the list, but that were semantically related to words in the list, then participants often mistaken them as being on the list, meaning they committed so-called false alarms. What is interesting is that they did so much more for synonyms than antonyms, and much more, again, for synonyms than words that were just generally associated with the words for the list. So this seems to indicate that the mistakes we do in the context of the places where we get confused in long-term memory is semantics, not acoustics, which was the case in short-term memory. Now, the second experiment is by Busfield in 1953. Now, what he did is he showed participants a list of words and he had them study it. Now, unbeknownst to the participants, the list of words, the words in the list, rather, came from four specific categories of words, which you see here: animals, names, professions, and vegetables. Now, participants saw the words in the list in completely randomized order. So, you might see a word from this category, then from the third category, then from the second, then from the fourth, etc. So the presentation was entirely randomized. But the words themselves in the list came from four specific semantic clusters. So participants were shown the list, so they knew they had to study it for later recall. Then after a 10-minute delay period, and this was again to ensure that participants, that this would be a test of long-term memory and not of short-term memory. After a period of delay, 10 minutes, participants would be asked to just free recall as many words as they could. So, it doesn't matter what order, just tell me all the words you remember. Turns out, participants recall items in semantic clusters, meaning they seem to have a tendency not to recall words in any random order, whatever comes to mind, but to typically recall words from a similar category. So maybe they would say zebra, and then go, oh yeah, wait, wildcat, leopard, reindeer, chipmunk, Adam. Okay, yeah, Adam, Oswald, Johnson, Otto, Wallace, and then, the typist, right? Yeah, so, also milkman and florist and plumber. They would recall in these semantic clusters. So they would show a tendency to recall by semantic grouping more so than you'd expect just by chance. So there was a clear tendency to use semantics as an organizing principle in how they recalled information. So this must reveal that there has to be an underlying spontaneous tendency in the human mind and long-term memory to organize information according to its semantics. So again, these two experiments together really show that in long-term memory, information is probably encoded in a semantic manner.